Welcome everyone to Module 7, Requirements Analysis and Design Definition, or RADD. If earlier modules were about discovering and managing what stakeholders need, this one is about analyzing, refining, and designing how those needs will be satisfied. Think of it as moving from the what to the how. This is where a business analyst begins to transform stakeholder wishes into structured, validated, and actionable solution designs. In BABOK terms, RAD terms, RAD is the knowledge area that takes elicited requirements, the raw material, and processes them into something ready for solution implementation. It's a bit like an architect translating a client's dream home description into blueprints that engineers and builders can actually construct. We'll cover 6 major tasks that guide this process, from specifying requirements all the way to analyzing potential value and recommending a final solution. By the end of this module, you'll see how RAD provides both structure and creativity, ensuring your business analysis delivers not just documentation, but real business outcomes. In this module, our learning journey has 4 key objectives. First, you'll master the structure of RAD, understanding its purpose, scope, and how it connects to other BABOK knowledge areas like requirements lifecycle management and strategy analysis. Second, you'll develop proficiency in RAD's 6 core tasks. These are the practical steps every analyst uses to specify, verify, validate, and design requirements effectively. Third, we'll examine strategic architecture, how requirements, business goals, and design options interconnect. You'll learn to see the bigger picture and how each requirement fits within the overall enterprise ecosystem. And finally, you'll apply essential BABOK techniques, such as data modeling, use cases, process modeling, decision analysis, and prototyping, each one a cornerstone of professional practice and certification success. By mastering these areas, you'll gain the ability to guide your team and stakeholders confidently, from raw ideas to validated, value-driven solutions. Let's start by defining what RADD truly represents. Requirements Analysis and Design Definition describes the structured process through which business analysts transform elicited requirements into well-defined, validated, and value-driven designs. In simpler terms, this is the stage where we convert needs into solutions. RAD sits at the intersection of understanding stakeholder needs and specifying actionable design components. Its core purpose is to ensure that what gets delivered, a system, a process, a policy, or a product, not only works but genuinely meets business objectives and creates measurable value. It's about ensuring alignment between the problem space, what's needed, and the solution space, what's being built. The primary focus areas of RAD include modeling, creating structured and visual representations that communicate complex ideas clearly. Verification, checking the internal quality of requirements, completeness, consistency, feasibility. Validation, confirming that requirements and designs solve the right business problems. Value analysis, ensuring every proposed design option delivers tangible business value. So, in essence, RADD is where analytical precision meets creative design thinking. It's the engine room of business analysis. According to BABOK v3, there are 6 major tasks that make up the RAD process. Each one builds upon the previous, forming a logical and iterative framework. Specify and model requirements. This is where we represent requirements in models, diagrams, and text to ensure clarity and shared understanding. Verify requirements, ensuring that requirements are of high quality, complete, consistent, and feasible. Validate requirements, confirming that the requirements actually deliver business value and align with strategic goals. Define requirements architecture, structuring all requirements into a cohesive framework showing their relationships, dependencies, and hierarchy. Define design options, identifying different ways to satisfy requirements, often comparing build versus buy or alternative approaches. Analyze potential value and recommend a solution, assessing trade-offs and recommending the best fit solution based on value, cost, risk, and feasibility. You'll notice that these tasks form a continuum, from definition to decision-making. And while they appear sequential, in reality, they are iterative. You may revisit earlier steps as new insights or constraints emerge. This foundational task is about representation, taking what was elicited and giving it structure and meaning. When you specify and model requirements, you make abstract ideas concrete. For instance, rather than saying, the system should handle customer data, you create a data model that shows the relationships between customers, accounts, and transactions. Or, you build use cases that capture exactly how users will interact with the system to achieve specific goals. Some common modeling techniques include data modeling, defining entities, attributes, and their interconnections. Use cases, describing user-system interactions step by step. Process modeling, illustrating workflows, activities, and decisions. Prototyping, building interactive or visual previews to test usability and flow. Each model type serves a different audience. Technical teams love precision. Business stakeholders prefer simplicity and visuals. A professional tip: use the level of detail that best fits the audience's cognitive load. Too much detail too soon can overwhelm. Too little detail can create ambiguity. Ultimately, this task creates alignment, so that everyone shares the same mental picture of what needs to be delivered. Verification is the quality gate of RADD. Before any requirement moves forward, it must be checked for completeness, correctness, consistency, feasibility, and testability. Let's go through these 5 verification criteria. Complete. Every necessary detail is captured, no gaps that could cause confusion later. Consistent. No contradictions between different requirements. Correct. The requirement accurately reflects stakeholder intent. Feasible. It can realistically be implemented within time, budget, and technology constraints. Testable. You can verify its fulfillment objectively through testing or demonstration. For example, in a payroll automation project, a requirement stating system should calculate salaries automatically is incomplete. We'd verify by asking, does it account for bonuses, taxes, or deductions? Verification often uses structured peer reviews, walkthroughs, and acceptance checklists. Remember, verification doesn't just improve quality, it saves cost. Catching an error in the analysis phase might cost $100 to fix. If that same issue surfaces after deployment, it could cost $10,000. Verification is your safeguard against expensive surprises. Where verification ensures correctness, validation ensures relevance and value. We're asking the ultimate question: are we building the right thing? Validation confirms that requirements solve the right business problems, align with organizational strategy, and deliver outcomes that stakeholders truly care about. Here are 4 critical validation questions to consider. Does this requirement address the real root cause, not just a symptom? Is it consistent with strategic goals? Are stakeholders genuinely satisfied with its intent and implications? Will it deliver measurable business value once implemented? Common validation techniques include prototyping, scenario analysis, workshops, and value analysis. For example, in a hospital management system, adding more patient data fields might seem useful, but validation could reveal that it slows down nurses' workflows, reducing efficiency. So, validation ensures that requirements are both desirable and beneficial, not just technically sound. This stage often ends with stakeholder sign-off on validated requirements documentation, confirming that we're ready to move towards solution design. This is where analytical clarity meets structural organization. The requirements architecture is essentially your framework for connecting the dots. It shows how business requirements decompose into stakeholder, solution, and functional requirements, and how all these layers relate to one another. Let's break down its three core components: hierarchical structure, business toward stakeholder, toward solution, toward functional, toward non-functional requirements. Each layer adds more specificity and granularity. Traceability links. These links establish cause and effect relationships, ensuring that if one element changes, you know exactly what else is impacted. Design alignment. Your requirements must align with enterprise architecture and solution design principles, maintaining consistency across systems and departments. For example, if your company already follows an enterprise-wide data standard, your requirements architecture must respect that, not reinvent it. The output here is usually a requirements architecture diagram or repository structure that helps teams navigate complexity and dependencies efficiently. In essence, architecture transforms chaos into clarity. This is the creative yet analytical part of business analysis. In this task, we identify and evaluate different design alternatives that can fulfill the validated requirements. Instead of jumping straight to a single solution, we compare multiple ones to find the best fit. The design options process follows 3 steps: brainstorm, generate creative and feasible options, describe, detail features, assumptions, and constraints for each, evaluate, assess trade-offs based on cost, risk, timeline, and performance. Let's consider an example. A retail chain wants an inventory tracking system. Option A: build a custom in-house solution for full control. Option B: adopt a cloud-based SaaS platform for faster deployment. The BA compares both options using factors like cost of implementation and operations, risk of failure or dependency, performance metrics like scalability and uptime, timeline to deliver, complexity of integration. Key techniques include decision analysis, feasibility studies, and prototyping. The goal here is to ensure every recommendation is evidence-based, balanced, and aligned with organizational priorities. This final task closes the loop. After exploring and evaluating design options, it's time to recommend the one that delivers the greatest net value. The process has 3 main steps. Quantify benefits such as revenue gains, cost savings, or improved customer satisfaction. Evaluate benefits versus costs and risks. Weigh expected benefits against financial costs, technical risk, and organizational impact. Select and recommend. Present the final recommendation backed by solid evidence and clear rationale. For example, in a digital banking initiative, you may find that automating loan approval reduces manual effort by 40%, but carries an upfront technology investment. By analyzing ROI, you justify the business case convincingly. Techniques such as cost-benefit analysis, SWOT analysis, value modeling, and decision matrices are crucial here. Outputs include a recommended solution, supporting documentation, and a roadmap for implementation. At this stage, your analytical work becomes strategic influence. You're helping leadership make informed, value-based decisions. To perform these tasks effectively, BABOK Ref offers a toolkit of specialized techniques, each enhancing precision and communication. Let's look at the key ones. Data modeling defines how information is structured, stored, and related, ideal for understanding database and entity relationships. Use cases describe user system interactions step by step, clarifying what functionality is required for each actor. Process modeling maps workflows, decisions, and activities, for instance, showing how a loan request moves from submission to approval. Decision analysis compares design alternatives using structured scoring models and weighted criteria, ensuring transparency in selection. Prototyping creates interactive previews of designs, allowing stakeholders to visualize and validate functionality before development begins. In practice, These techniques are often combined. For instance, data models support process diagrams, while prototypes validate both usability and flow. Mastering them ensures not only exam readiness, but real-world effectiveness as a business analyst. Let's apply everything with a real-world scenario. A financial services firm wants to implement an automated loan approval system to reduce manual work, speed up decisions, and improve customer satisfaction. Here's how the BA applies all 6 RAD tasks. Specify and model. Build data models for customer, loan, and decision entities. Create use cases for application and approval workflows. Visualize the automation process. Verify. Conduct structured reviews for completeness, consistency, and testability. Confirm technical feasibility within constraints. Validate. Hold workshops with compliance officers and loan teams to ensure the solution addresses genuine pain points and strategic goals. Define architecture. Build a requirements hierarchy connecting business objectives to functional features. Create a traceability matrix. Define design options. Option A, custom in-house build for flexibility. Option B, commercial off-the-shelf COTS solution for faster rollout. Recommend solution. Conduct ROI and cost-benefit analysis. Recommend option B, due to lower risk, 60% faster time to market, and projected 40% reduction in loan processing time. This example demonstrates how RAD brings analytical discipline to creative solutioning, turning uncertainty into clarity and business value. To excel at RAD, professionals follow a few best practices. Maintain clear boundaries. Separate requirements, what from designs, how. Mixing them leads to confusion and premature solutioning. Employ multiple modeling techniques. Different stakeholders absorb information differently. Use a mix of visuals, narratives, and diagrams for broader understanding. Engage stakeholders continuously. Keep them involved throughout verification and validation. It builds commitment and prevents misalignment. Document design rationale. Always record why specific design choices were made or rejected. This is vital during audits, onboarding, or later enhancements. Establish comprehensive traceability. Link each requirement to business objectives, design elements, and test cases. It ensures no requirement loses purpose or connection. Iterate and refine. RADD is not linear. Be ready to revisit earlier stages as insights evolve. Continuous iteration improves quality and alignment. These practices distinguish expert analysts. They balance structure with flexibility and precision with collaboration. As we close Module 7, let's recap the essence of requirements analysis and design definition. RADD connects business needs to validated, actionable designs that deliver measurable value. The 6 essential tasks are: specify and model requirements, verify requirements, validate requirements, define requirements architecture, define design options, analyze potential value and recommend a solution. The key deliverables you'll produce include a requirements architecture that shows structure and relationships, design options with trade-off analysis, a recommended solution supported by quantitative and qualitative rationale. Remember, techniques like prototyping, data modeling, and decision analysis are your professional tools for turning theory into practical, high-impact work. Mastering RDD means you don't just write requirements, you architect solutions, align stakeholders, and drive strategic outcomes. And that's what separates a good business analyst from a project with situations that seem to be more heavy than a worker.